Good day, grade 12. Here with me, I have question 6, which is on financial mathematics. Financial mathematics is an easy concept, which is mathematics that involves around finances. All right. So we are having question 6, which is 15 marks. That is usually how many points financial maths will be in your paper 1. Okay, financial maths is a paper 1 topic, and it's a very interesting topic. All right. So with financial maths, that's why we discuss finances, money. Okay. Now we are going to go through some notes before we can start with our question 6 and try to understand some of the things before we can actually answer the questions, so that the time we start answering question 6, we have an idea or a clear understanding of what we are dealing with. Now, with 6.1, all right, I've read the question. Sandile bought a car for 180,000 rands. Okay. The value of the car depreciates. To depreciate is to lose value. Okay. So the value of the car depreciated at 15% per annum according to the reducing balance method. Okay. This is from grade 11. The book value, okay, the value at that particular time of Sandile's car is now 79,866 rands 96 cents. Okay. So when I look at 6.1, this is a grade 11 problem. Okay. So with 6.1, we've got two types of interest. That's where I want us to start on notes. Two types of interest. We have what we call a simple interest and what we call a compound interest. Okay. So these are the two types of interest that we dealt with in grade 11. So what is a simple interest? This is a fixed interest. If you have taken someone's money and they tell you that you have to pay in 5 months' time, and the interest charged per month until the 5th month is 20 rands, it means every end of each month there will be a plus 20 rands that is added on the initial amount which you would have taken. Okay, so simple interest is such an interest which is fixed. Okay, then this is the formula that we use when we are dealing with simple interest, where A is the total amount which would have accumulated at the end of the period, okay, or what we call the accumulated amount, okay, in rands, and then P being the amount that you started with. We normally call it the principal amount or the initial amount, okay, which is also calculated in rands. And then we have I, which is what we call the rate of interest or the interest rate, and usually it will be quoted in the statement as in percentages, and when you use it in calculations, we normally write it in decimal form. Okay, and then N is the period of time the money is taken for. Okay, all right, so now it's the period or the time. Now, having said that, what is the opposite of simple interest? Remember, with simple interest, we are saying you start with a certain amount of money, then by the end of the period, you'll be having more than what you started with. Okay, but if you bought something with a particular amount of money, then by the end of the period, you have it weighs or it's actually depreciated in price from what it was before. Then now we are talking about something which is opposite what we have spoken about. Okay, so what is the opposite of simple interest? It will be what we call simple decay. Remember, when stuff decay, they are getting smaller and smaller. So the amount of a good or anything that you buy will with time become lesser and lesser. Hence, when something is on the market, it starts with a high price where only a few people can afford it. But after some time, it loses value, and more other products are being manufactured, more goods, and the price is now less. Okay, we can all buy. Now that is simple decay, the opposite of simple interest. And usually we don't call it simple decay. Okay, we also call it the straight line depreciation method. So it is also known as the straight line depreciation method. Of course, with simple interest, we are having more at the end of the period, but with simple decay or the straight line method, we are having some depreciation, and the final amount will be smaller than the initial amount. So that's why we have a negative in the formula. Okay. Then also with depreciation, remember P is what you start with, the amount, original pricing of a good or original amount, and then A is the final amount. So if goods are losing value, or anything that we start with loses value, then it means the initial amount will always be bigger than the final amount. You agree with me? So P will always be greater than A due to depreciation. But with simple interest, A will always be greater than P. Now, compound interest, the second type of interest that we have, here we do not have a fixed interest amount. Okay, here we have an exponentially increasing interest or growth. So what is the meaning of this? The meaning is that if, for an example, in the you borrow 10,000, and then in 1 month time when you start repaying back, interest is, let's say, 400 rand. In the second month, it won't be 400 rand. It will be slightly more than 400, although not too bad. Okay, maybe 411 rand. And then in the third month, maybe 422 rand. Then maybe in the fifth month, 437 rands, etc. So the interest keeps on rising exponentially. Okay, very important. That is your compound interest. The formula that we use to find the compound interest is A equals to P, all multiplied by 1 plus I, all to the power of n. Okay, I've spoken about exponentially increasing interest, and we see an exponent to the power of n. I hope that will help you to remember. Now, this type of interest may be compounded. Okay, what is to compound? That is how the number of times amount of money will accumulate interest. Okay, so we can accumulate, we can compound annually, meaning each and every end of each year there's an interest accumulated, which we also call yearly, or we can compound daily, meaning each and every end of each day the amount accumulates interest, or we can compound quarterly, meaning each and every end of 3 months the amount of money accumulates interest, or we can compound semi-annually, meaning each and every end of 6 months, which will be 2 6 months in a year, we accumulate interest. And then we can also compound weekly, meaning each and every end of each week your amount, maybe your investment, accumulates interest. Or lastly, we can compound monthly, which is the most famous compounding in our financial maths. So end of each month will be accumulating interest. Okay, that is just to say how many times does your principal amount accumulate interest. Okay, now having said that, remember compound interest, we are saying the investment or the amount of money that we start with accumulates interest exponentially. Okay, but what will be the opposite of that? The opposite of compound interest will be what we call compound decay. Okay, so here stuff or things are losing value. All right, goods especially will lose value. So if I bought something for 80,000 rand, after 5 years you may find that it is about 48,000. Okay, rand. So that is to decay. Now the compound decay, we don't usually use these words. Compound decay, we call it the reducing balance method. Okay, so we call it the reducing balance method, and it's also known like that. Okay, Most of the times we call it the reducing balance method, as you saw in the exam question that I posted. We said reducing balance method. Now, the formula for the reducing balance method is A equals to P, 1 minus, look at that, it's a minus because there is a loss in value, and then minus I all to the power of N. Okay, so the difference is just the plus and the minus. And then what do we know? Since there is depreciation, meaning what we start with initially will be bigger than what we end up with finally. So P will always be greater than A due to depreciation. Okay. Now next up, we want to look at the different compoundings. Okay. So by the way, the letter that we use, which represents compounding, how many times your money accumulates interest, is M. Okay. So if you are compounding daily, how many days are there in a year? 365. So M equals to 365. If we are compounding half yearly, how many halves are there in a year? There is 2. So M is equals to 2. Then if you are compounding quarterly, how many quarters do you have in a year? There are 4 3 months or 4 quarters in a year. Okay, which is 3, 6, 9, 12 months. So that is 4. So quarterly M will be equals to 4. And then monthly, how many months do we have in a year? We have 12 months. M will be equals to 12. And then yearly or annually, how many? Okay, in a year, there's just a complete year, which is just 1. So when compounding is yearly or annually, we assume M to be equals to 1. Okay, very important. Now, the more compounding, the more interest accumulated. That is true. If we take the same amount of money, myself and yourself, but my amount of money in the bank is compounded monthly, and then yours is compounded daily. Who's going to have more? It's yourself, because your money will accumulate interest each and every day, whereas mine will accumulate interest at the end of each month. Okay, so the more compounding, the greater interest accumulated. I've already explained M is the symbol for compounding, and we've also spoken about exponential growth, which is compound interest. Okay, and another thing that I want us to talk about is which option would be best if you were to maybe put in your money in the bank. The one where you get a fixed interest or an exponential increasing interest, it would be the exponential growth. Okay, exponentially increasing interest, the compound interest, is the better option. Okay, they will normally ask you which option is best, so you'll need to think of that. Okay, so it's the best option than the simple interest. I've already said that. Again, terminology is important in financial math. They will usually talk about what we call a hire purchase, which is a short-term loan, and they will also talk about what we call inflation. Inflation being the general increase in the prices of goods and services. So whenever they talk about hire purchase, just know that it associates with simple interest. Okay, and then whenever they talk about inflation, which is an exponential increase in the price of goods and services like bread, you find that on a particular year bread was 5 rands, then the following year it was 5.40, the other year it was 6.10, then the other year 7.90, etc. That is exponential growth. So inflation associates with compound interest. Okay, especially in terms of formulas. For hire purchase, the formula will be for simple interest, and for inflation, the formula will be for compound interest. Okay, then when I look at 6.2, now we're going for notes on 6.2. Exactly 10 months ago, a bank granted Jane a loan, underline a loan, okay, a loan of 800,000 at an interest rate of 10.25% per annum compounded monthly. What do we know? We know that if compounded monthly, then M will be equals to 12, okay? But The bank stipulated that the loan must be repaid over 20 years. What is 20 years? The period in which the loan must be repaid. And must be repaid by means of monthly repayments of. So what is this 7,853 rands 15 cents? This is your monthly installment. Okay, this is how much you'll be paying each and every month to the bank in order to settle that 800,000 with interest. Okay, so monthly installments, we represent them by X. Okay, in our financial math. Now, this problem, okay, they said starting 1 month after the loan was granted. So this problem 6.2 is a grade 12 problem. Okay, it's a grade 12 problem, and I want us to look at the notes on 6.2. As written down here, it's relevant to grade 12. So if you're a grade 11 watching this video, just know this is not for you for now, until later. Now, when we are dealing with financial math in grade 12, we introduced two types of annuities. Okay, remember in grade 11, P is an amount of money which is only put once. Okay, but with annuities, we are saying by end of each month, end of every each month, you are putting, let's say, 500, 500, 500, 500. So that becomes a monthly installment. This is an amount that you keep on paying into an account. It's not a once-off amount. Okay, so such accounts, we call them annuities. Okay, so we've got two types of annuities, which is a future value annuity as well as a present value annuity. Okay, you need to know what is the difference between the two annuities. But I think future value, future, here we are concerned about the future. It's more like we are saving for the future. Okay, then present, what we are presently taking, which are example can be a loan. Okay, now let's go to each one. What is the future value annuity? This is when we are having regular or continuous installments paid into an account. Okay, and also your future value annuity focuses on the following. It focuses on savings for the future as well as investments and what we call the sinking fund. Okay, there's also what we call a sinking fund. A sinking fund. So these are the focuses of future value annuity. Okay. Now let's go and check the formula that we use for the future value annuity. This is the formula. All right. This is the formula. 1 plus I to the power of n minus 1 all over I, where x, I have already said it, represents the equal monthly installments. That amount that you keep on paying each month. Okay. Then F represents the future value, which is what? The final amount at the end of the period. Okay. Of the investment or the saving or the sinking fund. And then I represents the interest rate. Okay. The interest rate, which is normally represented in percentages, but usually when we work with it, we write it as a decimal. Okay. And then N in that formula stands for period or time, as we already know it. Okay, very, very important. That's the formula that we use. Then on the other hand, we've got present value annuity. Present value annuity focuses on how much you're taking now. Example being a loan, and you need to repay it back with equal monthly installments. Okay, so there's a regular continuous installment payment into an account. Okay? Also, this annuity focuses on, this is very important, this annuity focuses on loan, present value, retirement, present value, sinking fund. This is very, very, very important. So, with the sinking fund, falls under of calculating the present value annuity, it is this one here. This is the formula. So the formula for present value annuity is P equals to X, all multiplied by 1 minus 1 plus I to the power of N all over I, okay? Where X, same as in future value annuity, equal monthly installments paid into an account, and then P being the total amount of the loan or retirement, okay? And then N being the period or the time taken to repay the loan or your retirement, and then I being the interest rate, okay, which is in percentages, or we work with it as decimals, okay. Very, very important. Now, having said that, both future value annuity and present value annuity, they are calculated in rands, okay. And also in financial maths, we usually round off money to 2 decimal places unless stated otherwise. This is money, so usually we round off to 2 decimal places, okay. And then let's talk about a sinking fund. What's a sinking fund? A sinking fund, say for an example, a BMW new model, okay. Let's say it costs 500,000, and you also have a BMW, but now yours is an old model that you own currently, and now weighs 250,000. The current price that you can sell it at is 250,000. So you want the new model, you have the old model, which is at 250,000 rands. Okay, which the 250,000 rands is its book value, the current amount that it weighs. So what are you going to do if you want the new model? It means you decide to trade in your old BMW model, and they agree to give you the new model, meaning they are going to set up a sinking fund. Why? This is what is going to happen. You are going to say this is the price of the new model minus the price of your old model. Then it means the outstanding balance will be 250,000. That is how much you will still need to pay. And this remaining amount will be paid using what we call a sinking fund. They will open up a sinking fund for you where you will need to pay that amount until you finish. Okay, so we call that a sinking fund. It's the amount that you need to pay, the remaining amount that you still need to pay using equal monthly installments. Okay, so the 250,000 rands will be the sinking fund amount, which is your F, the future value amount. Okay, so you'll pay it with monthly installments until you finish. Okay, that's a sinking fund. And then another thing that we need to understand is there is what we call an outstanding balance on a loan. Okay, say for example you take 500,000, then you're expected to pay it back over 260 months, and then after paying maybe for the 10 months, on your 10th payment, then you encounter problems. Okay, so it means the time you stop at the 10th payment, then you still be left with the other months. So there will be what you call an outstanding balance on that loan. And what's an outstanding balance on a loan? It's the amount of money remaining to settle off your debt. Okay, that's how much you need to settle. So there's 2 methods that we use when we calculate the outstanding balance of a loan. Okay, please note it down. There are 2 methods or 2 formulas that we use when we are finding the outstanding balance or balance outstanding of a loan. The first one is this one here, which is X bracket 1 minus 1 plus I to the power of. Please take note here, it's not just N like the present value annuity, it's N minus K, okay, to the power negative bracket N minus K bracket all over I. Okay, we'll explain what is the meaning of this. And then if you don't want to use that one, there's a longer formula and longer method that you can use, which is this one here. Okay, this is the whole formula. Quite a bigger formula, so I usually like using this one. But then, if you're using this one, this, remember, comes from your compound interest, which is A, and then this comes from your future value, which is F. So it's like you can find the outstanding balance by saying accumulated amount, which is A minus the future value annuity. Okay, but please also take note. Okay, it's P multiplied by 1 plus I all to the power of, we put K, not N. Okay, and I will explain what is the meaning of K. We put K. Okay, very, very important. So what is the meaning of N in the outstanding balance formulas? This is the total number of months expected to be paid. So if you are taking a loan for 3 years, compounded monthly, it means you'll be expected to pay it over 36 months. Right? So that is the total number of months expected to be paid. But what is K? K will be the number of months that we have actually paid, number of payments made. So if you are expected to pay over 36 months, then you end up paying over 25 months. It means K will be 25, where N will be 36. And that is the meaning of K. K is how many months you have actually paid, but N is how many months you're expected to pay. Okay, so N is the expected, the total number of payments that you must make, where K is the number of payments that you have actually made. Okay, so when you say N minus K, we see that this will be the number of remaining payments that should be made into the account. Okay, now let's go back to the question that we had and try to answer it. Sandile bought a car for 180,000. The value of the car depreciated, underline depreciated, meaning we must go to decay formula. Okay, at 15%, underline, this is your I, this is I. Okay, and then per annum according to the reducing balance. Take note, reducing balance, the book value, which is the amount that is currently weighing, of Sandile's car is, we are given that it's 79,866.96. Okay, so what is this? This will be our A. Okay, that will be our A, and then our P will be 180,000. Remember, P will always be bigger than A where there is depreciation. Now 6.1.1, how many years ago, what are we looking for? N, the period, did Sandile buy the car? So reducing balance method, we know that the formula will be A equals to P times 1 minus I to the power of N, right? And then where our A is 79,866.96, and then P is 180,000. Then our I is 15%, which is a 15 over 100 or a 0.15. Okay, then we are looking for N, hence N is an unknown. Now we divide both sides by 180,000. Then we are here, and then we can apply our logs. Okay, logarithm. So it will be N equals to the log of, remember this will be our base, and this will be our constant, right? So it will be N equals to log base 1 minus 0.15 of this value here. Okay, therefore our N being equals to 4,99999 recurring, which is approximately 5 years. Okay, so that means Sandile bought his car 5 years ago. All right, he bought his car 5 years ago. Then now let's go to 6.1.2. At exactly the same time that Sandile bought the car, Anil deposited 49,000 rands, okay, into a savings account at an interest rate of 10% per annum, compounded quarterly, meaning there will be growth. This will be compound interest problem. Okay, compounded quarterly, M is equals to 4. You remember? Has Anil accumulated enough money in his savings account to buy Sandile's car now? Remember, the car itself is weighing 79,866 rands 96 cents currently. So we want to see how much 49,000 will be at the end of 5 years. Okay, and whether Anil will be able to buy Sandile's car now. So this is a growth problem because money will accumulate interest. Okay, so we also saw that this is a compound interest problem where the initial amount that was deposited by Anil is 49,000 multiplied by 1 plus the interest rate was 10%, which is the same as 0,1. Then we divide the interest rate with what? With the compounding, okay, which was quarterly. So we divide by 4 and you must also multiply by 4. So that means the period and the interest rate must be in the same mode, okay. They must be in the same mode. So then Anil has 80,292 rands 21 cents in 5 years time, where the car in 5 years 5 over 12. 4 years, we are looking for the new monthly installment effect. But take note, the month that Jane skips, the 3 months that Jane skips, it means the balance actually accumulated interest through the compound interest. Okay, so what we need to do first is to find how much okay for the remaining months. So when we do that, we use our compound interest. We want to know how much was the balance by the end of the 3 months that she missed. Okay, so this was how much we had at the end of the sixth payment, which is our P now, and then 1 plus the same interest rate and the same compounding, which is monthly, divided by 12. But remember, no need to multiply by 12 here because this is three months. Okay, so we are compounding that amount for 3 months so that we know end of 3 months how much will it be. So it happened that the amount was now 814,263 rands 30 cents. Okay, so this is how much was outstanding by the end of the 9th payment. Remember, it was 6th payment where Jane stopped, plus the 3 payments she missed, which makes a total of 9 payments. Okay, so by the end of the 9th payment, this was how much was outstanding. And then now what are we going to do? We are going to take this as the initial amount of the loan, which will be our P in the loan formula, and then we are looking for X. Okay, where the interest rate as well as the period are still the same. So remember, we have paid 9 payments out of the total number of payments that was supposed to be paid, which is 240. So it means now we will then be having 231 remaining payments, right? Hence, I've got 231. Remember, N minus K. What will be N? N will be our 240. What will be K? It will be 9 payments. Therefore, that giving us 231 payments remaining. Then making X the subject of the formula, we found that the new monthly installment that needs to be paid so that we finish at the same time is 8,089 rand 20 cents. So Jane's increased monthly installment now is 8,089 rand 20 cents. Okay. Now the other thing that we can do is we can actually look at the second method. Okay, so the second method that I've done is for this problem here, as I promised that will come back, is for 6.2.1. okay, that's the second method. So the second method will be, I'll be using the longer outstanding balance formula. Okay, where I start by finding A first. So this will be 800,000, which is what was taken, and then multiply by 1 plus 0,1025 over 12 to the power of 6 payments made. You remember? So that means end of the 6 payments, this is how much is out there. This is how much we have, which is 841,885,56, 841,885 rands 56 cents. And then now we find the future value, which will be X all multiplied by 1 plus I to the power of K minus 1 over I, and then our X being the monthly installment, okay, which is 7,853.15 cents, which was given, and then with all the substitution, our future value now was 48,136 rands 62 cents. So how do we find the outstanding balance using that other formula? It's A minus F. I think I did explain. So it will be A minus F, and we found that the outstanding balance was 793,748 rands 94 cents. The slight difference in this answer and the answer that we got in 6.2.1 method number 1 is due to rounding off. Okay, well done, and that is how you were expected to do this problem. So please practice as many as possible questions on financial math, and also watch revision number 2, 3, and 4 on financial maths. Thank you.